All right, welcome to tonight's video on critical numbers and how to use them to find where the intervals of the functions are increasing and decreasing. So when the function is critical numbers are basically numbers that make the derivative zero or basically undefined. So in this picture above here, notice here, these numbers make the derivative either zero or undefined. If between these critical numbers the derivative is negative, then the function is decreasing. Because remember, the derivative stands for slope or rate of change. If the derivative is positive in those intervals, then it increases, like here. And if it's equal to zero, then it either has a maximum, minimum, or saddle point. If it's undefined, then it either has a vertical asymptote or a sharp turn. And we will talk about how to determine that in another section. All right, so examples here. So find the critical numbers of the function. So first, to find the critical numbers, you have to find the derivative. So when you take the derivative here using the power rule, you get that. Now, you set the derivative equal to zero, and then notice these are all divisible by -2. So we have 3x squared minus 4x minus 15. So when we factor here, the factors of -45 that add to -4 are -9 and +5. So when we factor, it's going to be -2 times 3x minus 9 and 3x plus 5. Well, here you can divide by 3, so you get -2 times x minus 3 times 3x plus 5. So your critical numbers are 3 and -5/3. So those are the two what we call critical numbers. Now, what we are going to do here is on a number line, we are going to create intervals with the critical numbers and put these numbers in each interval. So here I would choose like -3, here 0, here +4, and put them back in the derivative and see if it makes it positive or negative. What I usually do is just eyeball it here and see what happens. So if I put -3 here, that's a negative. -3 minus 3 is -6. Times -2. So if x equals -3, it's a negative, negative, and negative. So 3 negatives make it negative. X equals 0, you start off with -2, but then you have -3, and then you have +5. So negative, negative, positive is positive. X equals 4, you have negative, positive, positive, so it's negative. So now what this means is that the function is increasing. It's increasing where it's positive. So here between -5/3 and +3, and it's decreasing where the derivative is negative. So from -infinity to -5/3, and from 3 to infinity. And if you look at the graph that I provided, you can see that, here's -5/3, here's 3. So notice it increases between them, but it decreases everywhere else. All right, next one. So now here, to take the derivative of this, you have to do the quotient rule. Remember the quotient rule. If u is the numerator and v is the denominator, remember the quotient rule. This is u and that's v. It's u prime v minus v prime u all over v squared. So let's take the derivative here. So it's 2x. Derivative here is also 2x. So basically it's going to be 2x times x squared minus 4 minus 2x times x squared minus 1 all over x squared minus 4 squared. So when we simplify here, we get 2x to the third minus 8x minus 2x to the third plus 2x, because remember you have to distribute the negative with it. And then it's x squared minus 4 squared. Those cancel, so you get negative 6x over x squared minus 4 squared. Now for fractions, remember the critical numbers make the numerator and denominator 0. So the numerator is 0 when x is 0. The denominator is 0 when x is plus or minus 2. So there are 3 critical numbers here. So it's negative 2, 0, positive 2. So we have to test in 4 different intervals. So when we put it in the fraction here, notice we get positive over positive, so that's positive, because anything we put in here is going to be positive. So here it's also positive over positive. And then for 1, it's going to be negative over positive. And then for 3, it's also going to be negative over positive. So notice here, we can say the function is increasing from negative infinity to negative 2, union negative 2 to 0. You cannot say from negative infinity to 0 because remember at negative 2 it's undefined, so it stops there. And then f of x is decreasing on the interval from 0 to 2 and 2 to infinity. And if you notice the picture, it matches up, right? The vertical asymptote's at 2 and negative 2. Notice it increases here, increases there, but then after 0, decrease and decrease. All right, next one. Here you got some trig. So when we take the derivative here, it's the square root of 3. And then the derivative of cosine is sine, so it's plus 2 sine x. All right, now we have to set the derivative equal to 0. So you get negative square root of 3 equals 2 sine x. Negative square root of 3 over 2 equals sine x. So now, where does the sine equal negative square root of 3 between 0 and 2 pi? Well, in the first quadrant, it's the pi over 3 angle, but sine is negative in the third and fourth, so it would be 4 pi over 3 and 5 pi over 3. Let me rewind a little bit. Sorry, I should have made this, because remember, derivative of cosine is negative sine x. So it should be a negative and negative. So this is a positive, so this is actually pi over 3 and 2 pi over 3. So these are our critical numbers. So now when you make the number line, you'll start with 0, because remember, it can only be between 0 and 2 pi. 2 pi over 3, and then it ends with 2 pi. So you just put, like, for example, between 0 and pi over 3 would be pi over 6. Here, this would be between pi over 3 and 2 pi over 3. We could do pi over 4. And then between 2 pi over 3 and 2 pi, we could do pi. So when you put the square root of 3 minus 2 sine pi over 6, right? So square root of 3 minus 2 times 1/2, that's the square root of 3 minus 1. Well, that's going to be positive. And then for pi over 4, you change this basically to pi over 4. So it's going to be square root of 2 over 2. So it's the square root of 3 minus the square root of 2. So it's going to be positive. Sorry, I can't choose. Pi over 4 is less than pi. I should have chose pi over 2. So let's do pi over 2. The sine of pi over 2 is 1. So the square root of 3 minus 2, that's negative. And then when you put pi in, that makes this a 0. Square root of 3 minus 0, so that makes it positive. So f of x is increasing on the interval 0 to pi over 3 and 2 pi over 3 to 2 pi. And then it's decreasing from pi over 3 to 2 pi over 3. All right, that concludes our video for this evening. Have a good rest of your evening.